Hello students, today we will talk about the topic the deviations of guesses from ideal behavior. In our last lectures we have discussed about ideal guess or ideal guesses. What were ideal guesses? The guesses which obey the equation or which obey all the guess laws at all the ranges of temperatures and pressures. These are named as ideal gases. Ideal gases were defined as the gases which obey all gas laws like Boyle's law, Charles' law, Avogadro's law, Gay-Lussac's law, right? We have already learned about these gas laws at all the ranges of temperatures and pressures. Means PV was equal to nRT. The ideal gases were gases which obey this ideal gas equation at all the temperatures and pressure was named as ideal gases, right? Today we will talk about real gases. So if a gas is not an ideal gas, it means it will not obey this equation. PV will not equal to nRT, right? PV is equal to nRT. If a gas is not going to obey this equation, it means PV won't be equal to nRT. If PV is not equal to nRT, that is named as a real gas, or that is the gas which deviated from this ideal behavior, this ideal gas equation. We know very well in your mathematical classes you learned about this term. The value of A is equal to 1, right? If your teacher says A is not equal to 1, right? A is equal to 1, then it's okay. That will obey ideal gas equation. If he talks about this, that A is not equal to 1, it means you will think in your mind either A is greater than 1 or A is less than 1. Similarly, for real gas behavior or the deviation from ideal gas behavior, for real gases, PV is not equal to nRT. It means if PV is not equal to nRT, then either PV will be greater than nRT or PV will become less than nRT. So if PV is not equal to nRT means PV is either greater than nRT or PV is less than nRT. To express this greater than or less than behavior or deviations, the scientists gave a factor that was named as compressibility factor. Compressibility factor, and that is denoted with an alphabet that is Z. Compressibility factor. So if Z equal to 1, it means now we know very well PV is equal to Z RT. P was pressure, V was volume, Z is compressibility factor to show the deviation from the ideal gas behavior, RT, because now PV is not equal to RT, right? So it means for N is equal to 1, number of moles if we take here 1, right? Then Z will be either greater than 1, less than 1, or if Z is equal to 1, it means that is an ideal gas. PV is equal to nRT. If either Z is greater than 1, it may gas will show a positive deviation from the ideal gas behavior. That gas will show a positive deviation from the ideal gas behavior. If Z is less than 1, it means gas will show negative deviation from the ideal gas behavior, right? So it can either show the positive deviation or negative deviation. So similarly, if in your previous classes you learned about this, for example, if A is equal to 0, that is fixed, its value is 0. If A is not equal to 0, like Z is not equal to 1, it means either A will be greater than 0, means positive, or A will be less than 0, means negative. Similarly, if Z is equal to 1, it will show ideal gas behavior, PV will become equal to RT. If Z is greater than 1 or less than 1, it will show positive deviation or negative deviation. That is named as real gas behavior, which is shown by a compressibility factor, right? So for this compressibility factor, we know the real gas when behaves like an ideal gas, then that is named as Boyle's temperature. Boyle's temperature is the temperature where your real gas behaves like an ideal gas. Means this that will become equal to 1. So PV will become equal to nRT. If n is equal to 1, PV will become equal to RT. So that is named as real gas behavior, right? So where Z will be equal to PV upon nRT. If n is equal to 1, then PV upon RT. So that is named as real gas behavior.